Let's solve a problem on anti-coordinate system. The problem goes like this. So there is a path A, B, C, D, E and F, out of which ABC is a semicircular path whose radius of curvature is 2 meter. It's a semicircle. Similarly, CDE is another part of the uh, mm, path which is also a semicircle of radius 1 meter, and EF is a straight line. On this path, a particle is moving with a speed of 5 meters per second. Okay, so now once 5 meters per second, and as soon as we say that a path is given and on that path a particle is moving, the first thing that should come to our mind is anti-coordinate system. That is the configuration. Okay, a particle moving on a given path, that should call for anti-coordinate system. And then we are asked to find out three accelerations. So acceleration 1 at this point 1, similarly acceleration 2 and acceleration 3. So these three accelerations we are required to find out. Now, because we said that this is a very um, straightforward question which should call for anti-coordinate system, let's start with writing the expression for the acceleration. Okay, so how do we write that? So this is the expression, right? Okay, so this is how we should evaluate acceleration at any point in the anti-coordinate system. And this ds over dt is the speed which you see in the speedometer, and d square s by dt square is the time rate of change of speed. So for this problem we are given with ds over dt, right? It's given to be 5 meters per second. And what about d square s by dt square? It's 0 because we are given that the speed is constant. So the vehicle is moving at constant speed on that road. So this term is 0. Fine. Now, so this is done. So this is done. This is done. What about R? Now R at these three locations, you see. So these are also known. Fine. Let me write that. So R at the point 1 is 2 meters. Similarly, R at the point 2 is 1 meter. And R at point 3 is infinity. Right? So that means now this also is known. So what remains to be figured out are these two things, ET and EN. Now in general situation we know that ET you can find out from the expression dr is a function of s. Suppose r is a function of s, like ds, so that you can do. But in this specific problem, because the curves are so simple, so we will see that ET and EN should be evaluated directly from the geometry itself. Okay, so let's try to find out A1 then. Okay, A1. How much is A1? Anyways, this is 0, so we don't have to figure out this term for any of the accelerations. We should concentrate on this. So ds over dt is 5 square. R is 2 here, so 2. This term is done. And En. How much is En? Now let's see. Let's draw that first here. Now Et of the particle is in this direction, right? And En will be in this when the particle is at the point 1. So then can we write En to be what? Is it not just j cap, right? So that's how we can directly write that this is nothing but 12.5 j cap. Done. So then let's find out A2. A2, how to find out? Again, this term goes to 0 because d square s by dt square is 0, and this term comes out to be 5 square over r here is 1, so 1. But then we have to find out En. So do we know the value of En? Let's see. Now here Et is pointed in this direction, right? Sorry. Et in this direction and En in this direction. Fine. Now, and the angle theta is given to be 30 degree. So what should be En? En will it not be equal to, say in the x direction it is cosine of 30 degrees, and in the y direction it's negative sine of 30 to j cap, right? So just substitute these values here to get A2 to be equal to so it will come out to be 21.65. This is in the I direction. Sorry, here I have missed out I, right? Minus it's 12.5 J. Okay, so this is A2. And what about A3? Now see, once we come to A3, it's a straight path, and so you can think that r is infinity, so this term goes to 0, so that's one way. Or simply you can think that on a straight path, when a particle moves with a constant speed, anyway its acceleration is going to be 0. So this is that. So we can write the units everywhere. So this is meter per second per second. This again is meter per second, and this is meter per second per second. So that is how you should find out acceleration. And the point which this example wanted to tell you is that you should look for Et and En, how to figure them out from the map of the road. Okay, in this case, because the map was simple, they were semicircles, in a Cartesian coordinate we could write the Et and En easily. Okay, so that's the gist of this problem basically. So let's meet with another problem in the video.